Hello, all you math kids out there! Yes, it's the big bad wolf, and I'm here to help you with your math. Today we're looking at multiplying and dividing rationals. Ooh, what big numbers those are! Ha ha ha. Here we go.
The Big Bad Wolf. Yes, one of the classic characters that we've all heard of. And he really gets a bad rap because he's not all that bad, right? He was just a little bit hungry. Can't blame him for that. Pretty much wolves get a bad rap in most things, except for a TV show called Game of Thrones. But yeah, if you're a wolf and you're in a kid's comic book story, you're basically not a good guy. I mean, for one of them, he just wanted to go and knock on some doors of some pigs and make some friends. But they kept saying no. I'd be upset too. I'd go and blow down their house as well. Anyways, today we're talking about multiplying and dividing rationals. We're not going to talk about the bad wolf, although it would be a fun topic. Rationals. What do I really mean? I really mean we're talking about multiplying and dividing fractions and decimals. So we're going to look at some common kind of concerns, maybe some top tips, and we'll kind of go from there. So one little reminder before we get going is if the signs are different. So if you're multiplying or dividing anything where the signs are different, then your answer is negative. This is something you just have to memorize. I don't have anything cool or catchy to go and help you with this one. So if things are different, then your answer is negative, and you can guess if the signs are the same. If the same, your answer is positive. And this is a cornerstone of your mathematical knowledge. Your answer is positive. So you really got to remember those ones. Hopefully you've already learned this. This is just a little review for everybody. Let's get into the action, shall we? So first we're going to start up with we're going to get rid of that. There we go. Let's start off with fractions, shall we? Let's start off with fractions. Do I have any kind of suggestions? Number one, always reduce your fractions before you start. Reduce before starting. That means cross-reducing and also just simplifying. So always do that first. And it is always a good thing to go and remember that, or just ask yourself, is your answer going to be positive or negative? And already have that in the back of your mind. So reduce before starting. And I also like, and this is my own personal kind of thing, convert everything to improper. So I hate mixed numbers. I really, really do. So I always convert everything to improper. Sometimes this isn't the most efficient way to do things, but I found it reduces the amount of mistakes and it makes things nice and simple. So let's start off. Here we go. Negative 2/3 bracket negative 5/7. Now you might be saying like, well, are we multiplying? Are we dividing? What are we doing? Well, don't forget, when something is beside a bracket, there is an imaginary multiplying sign there. So this is multiplying. You should be saying to yourself, oh, look, the signs are the same. Negative and negative, right? Those are the same. So my answer is going to be dun, 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 positive. I'm just writing down the positive sign because I just want to. You don't have to, though. Okay, so they're going to be positive. Can you reduce anything? Well, can you reduce 2/3? Nope. Can you reduce 5/7? Nope. Can you cross-reduce 5 and 3? Nope. Can you reduce 2 and 7? So that means we are just going to multiply across the top and across the bottom. That's what we're going to go and do. So let's go and do that. 2 times 5, that would give me 10. And 3 times 7, that would give me 21. There's my answer. Can you reduce it? Nope. And boom, there you go. Easy peasy lemon squeezy. That's right. That's what I just said. So I think it's like a kid saying that one, isn't it? A little bit. Other examples. Let's go with 3 2/3. There's that mixed number. Divided by, we'll talk about that in a second, -1 3/4. Okay, just a little reminder that when you divide fractions, think of KFC, not KFC, KCF. Keep, change, and flip. Keep, change, flip. There's a really catchy song you can go and Google if you want to go on YouTube and Google it. Keep, change, flip for dividing. So I want to keep this, I want to change this to multiplying, and I want to flip this. Now in order to do all that, you will need to go and follow one of my principles of convert everything to to improper fractions. So 3 times 3 plus 2, that would give me 11/3. I'm going to go and I'll go a little bit slow. So divided by this one. So this becomes 1 times 4 plus 3. So -7/4. And go from there. You know, there's a common kid mistake. There's a common kid mistake. I have seen enough times to mention this. I've seen this common kid mistake. I love showing common kid mistakes. Do you know what some students do? Oops, did I not close the bracket? Somebody's saying, you didn't close the bracket. I love the internet. Here we go. What's a common kid mistake? Some kids do this. This is what they think. They do this in their head. They say -1 times 4. And they say that is -4. This is what they're doing. And they say, then I have to add this one. So they say -4 plus 3. Wait, okay, that's -1. So that means my answer is going to be -1/4. And they think that this fraction converts to -1/4. That's what some students do. Remember, when you're converting to an improper, you don't even care about the sign. Just get rid of it. I guess I could have just erased it, right? I could have just erased it like this. So just get rid of it. So don't worry about that at all. Let's bring that back. So I just wanted to kind of talk about that. So keep, change, flip. Keep, change, flip. Don't forget about that. So I'm going to keep this one, 11/3. I'm going to change this to multiplying, and I'm going to flip this one. So it's going to be -4/7. Some students say, why is the negative sign there now? Why isn't it down there? It doesn't matter which one you put it on, top or bottom. It does not matter. Just choose. As long as you don't put it on both. Just choose one, top or bottom. I always say it floats to the top. So I always put it on the top. Here we go. Can you do any kind of reducing? No. So we're just going to go and multiply across the top and across the bottom. So I get -44/21. Can you reduce that? I don't think so. And that is your answer. Okay. Okay, well this multiplying, dividing rationals isn't too bad, is it? No. Fractions are pretty fun to go and do. They really, really are. And let's just do one more. Okay, one more. Let's go and do 6 and I don't know. Let's do 6 and 8/9. Let's make it negative. Let's make it negative. -6 and 8/9, and I'm gonna go and multiply it by a -4 and I don't know, 2/7. Sure, why not? Let's go and convert this. So 6 times 9, 54 plus 8. That's going to be 62/9. That's a -62/9. And I'm going to multiply that by 30/7. That's a -30/7. So a couple of things. You have a negative times a negative, so I'm going to have a positive. So I did want to kind of show that a little bit, so I'm doing this one. So I am going to have a positive. So we know that right away. We do have some reducing that we can go and do. We do have the cross reducing here. So right here we have these numbers have a factor of 3. So I'm going to make this become a 3 and make this become a negative 10. And is there anything else that we can go and do? I don't think there is. That's kind of annoying. So I just want to show you should always be kind of reducing as much as you can. We're going to go and multiply across the top and across the bottom. So 62 times 10, 620. And 3 times 7 is 21. And you can't reduce that, and there's your final answer. All right, on to decimals. Oops. There we go. Decimals. You ready? Oh yeah. Here we go. So decimals, let's get into an example. Let's say we had 2.4. And we're multiplying that by negative 1.65. Alrighty. So a few things when you're multiplying decimals. So let's see. Let's see. Think. So kind of like your thought process. Number one, is your answer going to be positive, or is it going to be negative? So going back to our original rules, this is a positive by a negative, so we know that our answer eventually is going to be negative. We know that. And the other thing I do like to look at when I'm multiplying decimals is count the decimal places in total. And that'll give you an idea of how many decimal places there should be in your answer. So let's take a look what that means. So if I looked at this one right now, how many places are there past the decimal on the right hand side? Well, that's 1. And over here, 1, 2. So in total, there are 3 decimal places. And that's just something to kind of keep in mind before you start going and doing your multiplying. So here we go. I always put the biggest number on top. I ignore the decimals completely. So 165 times 24. That's what I do. Okay, so I ignore the decimals completely. This is going to get in the way. I'm just going to go and erase this. Okay. So again, when you're multiplying, you should have had a lesson on this probably in what grade? I don't know. Grade 3? So this is what's happening. You're multiplying like this crazy algorithm. Here we go. Let's keep it in this color. 5 times 4 is 20. I carry a 2. 6 times 4 is 24 plus 2 is 26. I carry a 2. 1 times 4 is 4 plus 2 is 6. So there we go. I'm going to go and add a 0. Now, because I'm going in the second line now, so now I'm multiplying 165 by 2. So why do I add that 0? What you're really doing, you're actually not multiplying by 2. You're actually multiplying by 20. But to make life a little bit easier, I just put that 0. I put this 0 right here. So now I'm going 165 times 2. So if you wonder why you put that extra 0, that's why you do it. Here we go. 5 times 2 is 10. Carry a 1. 6 times 2 is 12. Add a 1. 13. And 1 times 2 is 2. Add 1. You get a 3. All right. Cool. Now we go and add. Get some more colors because we love colors. 0, 6, 9, and 3. That's my answer. 3,960. Yay! On to the next question. No, wait. Remember this. Do you remember that? Well, our decimal's here. And now we have to have 3 decimal places. So let's go and do that. 1, 2, 3. And put it right there. My answer is 3.96. So my answer is, there we go, 3.96. You might want to say 960. It doesn't really matter. The 0 doesn't add any kind of value to that. And some of you are yelling at the screen right now, of course. Don't worry. I was just seeing if you're paying attention. Is that really your answer? No, it's not. You know when a teacher says, do you really think the answer is that? Do you know when the teachers ask you that and you say, yes, I do? Teachers never ask you that if you're right. Okay, not never, but very rarely. Typically they're saying, hello, have you forgotten something? I'm giving you an opportunity right now. If you have a really nice teacher, they do that. So, of course, this was a positive by a negative. That means your answer has to be negative 3.96. Bum, 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 bum. There we go. First question is right. There we go. We have one more question to go. One more. Goodbye to that. We're going to stick around decimals. Students love decimals. Here we go. Negative 0.35. And we're going to go and divide it by negative 0. Oops, that's a point. There we go. 0.05. Okay. Oh, you want some fancy words to go and impress people? This is your divisor. This is the divisor. Okay, so that goes on the outside. We're going to do some long division right now. Oh yeah, yes we are. Okay, so little reminder, divisors can't have decimals. Divisor, no decimals. So you must ask the question, how are we going to do this? How, Math Jedi? How? Again, I'm going to ignore the signs right now. I know this is a negative times a negative, so I know my answer is going to be a positive. So now I'm just going to ignore the signs. Yay. I put that on the outside, 0.05. And I'm going to put this on the outside, 0.35. Now one thing is how we're going to go and get rid of that decimal is I'm going to go and move it to the right, 1, 2. If I move that to the right 2 spots, I must move this to the right 2 spots. Okay. So now I get a brand new question. And the brand new question is the following. 5 into 35. Well, how many times can 5 go into 35? The answer, of course, is 7. There you go. I just wanted to show you that rule about going and moving that. And of course, my answer is bing, positive. There you go. Multiplying and dividing rationals. Remember, the big bad wolf is not all that bad. Give the wolf a chance. Until next time, have a great day.
Thank you! I have now eaten the Math Jedi! Ha 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 ha! Maybe he'll be back for another edition of Math with Mr. Douglas, or maybe he'll stay in my belly. Until next time, go and subscribe.